So the way that we're going to solve this today, and that's correct, both those ways are correct, but if this gets like a little bit more complicated, is there's a way we can take a logarithm and write it into exponential form. And that is, if you remember, like, if it was like log base 2 of 8 equals x, something like that. You guys remember that? Then we wrote this as 2 to the x equals 8, right? And then so it would be 3, okay? So same idea, we could do it here just as x equals 6. We could say 10 to the first power equals x plus 6. And then you just subtract 6, so x is 4. So that's what we're going to do today as one of the ways we're going to solve them. This is the last section that we're going to go over on logarithms, and it kind of puts some of a lot of these different things we've learned together into solving some a little bit more difficult equations. So this is going to be one strategy, and overall it's going to be three different strategies we're going to talk about how to solve these equations. So this will be the first one, and so if you want to write some of these down, it'll be a good idea. Write some of these equations. It's kind of going to be like algebra 2 on steroids a little bit. Whereas we're going to use some logarithm stuff from pre-calculus, and then we're going to solve like some algebra 1, algebra 2 equations after we use those logarithm properties. So you need your thinking caps. Right? So this is in elementary school, right? Bring your thinking caps. Plug your thinking cap. All right, so we're going to solve a bunch of different equations that involve logarithms. So in general, there's 3 strategies, and we'll kind of go through them one by one. The first strategy is what we use to solve that warm-up question, and we'll solve several problems using this strategy. This is the easiest one, straightforward, I guess you could say. And that is, all we're going to do is take our logarithm and rewrite it into exponential form. We can do that right off the bat, and that'll be easiest. So you might want to write down then, well, like, how do you take a logarithmic form and write it to exponential? And we wrote this in the notes a little while ago. That's a little refresher here. If we have log base b of x equals y, it's called logarithmic form. To write that into exponential form, we say b to the y equals x. So the base becomes the big number, the number on the other side of the equal sign becomes the exponent, and then the x and the other side of the equation. So that's how we take something from logarithmic to exponential form. And then we would just solve it from there. So that's going to be our first strategy, is to take something that looks like this and make it look like that, and then we should be able to solve it. So let's do some problems using that first strategy. We already did the first one there, but I'll write it out again if you want. You can write it down. So this one doesn't have a log base. Anytime we don't have a log base, we just assume it's a 10 right here. So then we're just going to take this, rewrite it into exponential. We say 10 because that's our b, right? B to the y, so b to the first, or 10 to the first, equals x plus 6. And then it's just a 8th grade math problem, subtract 6, so x is 4. Yeah, so let's try that with the next one. See if we can take this logarithm and write it into exponential form. And take a second, maybe yourself there, and see if you can do that. Write that one into exponential. And after you do that, it's a pretty easy equation to solve. So it should be 3 to the second power equals 3x minus 1, right? Just the base, raise it to the other side. And then so just 9 equals 3x minus 1. And then it's just a 2-step equation there. add the 1 over, we get 10 equals 3x. So x is 10 thirds. All of these you can also plug in this to check them if you wanted to. If you plug this in, it would be 3 times 10 thirds. The 3 is a cancel, so you give me 10 minus 1, which is 9. So it would be log base 3 of 9, and then you plug it in. And that's just saying 3 squared equals 9, which is true. Always check it. All right, let's look at the next one here. So you'll have like 2 or 3 problems that use this exponential form on your assignment. But our next set of problems here looks a little bit different. The main difference is that there's not one logarithm anymore, right? It's not one logarithm equals a number. It's actually one logarithm equals another logarithm. So see if you could figure out a way to solve this one. Think about it for a minute. And use maybe just like some common math skill or technique that we used for a different type of problem that we solved equations last week. So if you're to solve log 5 of 2x plus 3 equals log 5 of 3, what could you do? Yeah. Okay, now you can't divide by log 5, you're saying like it's exponentiate it basically, right? Like say 5 to the... Okay, so you can't divide by a log, but the way that we get rid of them is you like exponentials, so you like say like 5 to each one and then we cancel. Right? Yeah, that would actually work. Yeah, if you did that, this would cancel, this would cancel. Right? And that's essentially what we're gonna do. Caleb, what were you gonna say?
Could you split the first one into log 5 2x plus log 5 3?
Okay, you could actually do that. I don't know that you'd want to, actually, sorry, no, you can't do that. You'd have to have it 2x times 3, and then you could split it into the plus. But that's a good thought. Good thing. So we're essentially going to do what Jason was saying, where like you do 5 to both sides, but it's actually even simpler than that. You guys remember when let's say we had like 5 to the 2x equals 5 to the 10th power. How do we solve something like that? Huh? How do you solve this? Yeah, you set the exponents equal to each other, right? Because these are the same, so you can just kind of ignore them, right? 2x is 10, and they're the same, then the exponents got to be equal. So if you follow the same logic, we got the same log bases, right? Log 5 and log 5. So if those are the same, well, the things inside of them got to be the same, right? So you can actually just set 2x plus 3 equal to 3. Because you got the same log bases on each side. And essentially all we're doing, like I said, what Lisa said there, we're doing like 5 to the on both sides, okay? You don't actually have to write that. If it's called exponentiating 5 on both sides, then that would cancel the log and cancel the log. So that's really what we're doing. But to make it even simpler, we can just say, you just set the insides equal to each other. So then it's just going to be subtracting 3. And then divide by 2, so x equals 0. And let's just double check and make sure that's right. If you plug 0 into here, you get 2 times 0, which is 0, plus 3 is 3. So you get log 5 of 3 equals log 5 of 3. Right. So this is our second way we're going to solve them. And that is, we're going to set the inside of the logs equal to each other. So if we have a log on each side, then we're going to set the inside of the logs equal to each other. Now this only works in certain scenarios where you have the same log base on each side. Okay, so let's try another, a little bit harder version of that. Oops, I want to go back actually. We'll solve this one here now. So we almost have the same scenario. We got a log 5 here, a log 5 here, we got a log 4 and a log 4. The only difference is these didn't have like a number there, right? This one does have a number. Which we got to get rid of that somehow before we can actually, before we're allowed to set the inside is equal. What can we do to get rid of that -2? Yeah. Right, yeah. So we have this log property that we've been using, where it says if you have a number in front, you can bring it up to the exponent up there. You don't want to divide. Some of the other class, a good idea, they said divide both sides, but then you haven't really solved the problem. You just sort of moved it to the other side. So yeah, how we want to do that is take that exponent up there, take that number as exponent. So then we write it as log 4 of x to the -2 equals log 4 of 9. So by moving it up there, we now have log 4 on both sides with like nothing else. We got what we're looking for. Now we can set the insides equal to each other. Now we just say x to the -2 equals 9. And some of these problems, and then also some of the problems you're going to do, this part is a bit challenging. You have to use some algebra 2 skills and things maybe haven't used a little bit. So it might be a bit challenging to solve a couple of these. With this one, the easiest way to solve it here, that I think you guys probably want to do, is anytime you have a negative exponent, is get rid of the negative exponent. And to do that, we have to rewrite this somehow. What is x to the -2 the same as? Yeah? Not quite, but almost. How do we get rid of a negative? Yeah, you put it on the bottom. So it's 1 over x squared. Because in general, like negative exponents aren't easy to work with and they're kind of intimidating. So if we can get rid of that negative power, then that's good. Okay, now from here, we need to get the x. So we also don't want to like variables in the bottoms of fractions. So let's just multiply it over there. We multiply the x squared over, and then have 1 equals 9x squared. Okay, a little bit closer now. What next? Right, about 9. So we got 1/9 equals x squared. And now we're almost got to x square root, right? So what's the square root of 1/9? Yeah, 1/3, right? So you take the square root of 1, which is 1, and the square root of 9, which is 3. And now, one thing that you have to remember with square roots is that generally we want to write like plus or minus symbol, right? All right, plus or minus. With logarithms, though, I'll write this for now, but before I was, so yeah. Is it okay to write as plus or minus 3? Or is it not okay? Why? Yeah. Right, exactly, yeah. So if we plug a number into here, it has to be a positive number. Logarithms only work for positive numbers, and this is what the graph looks like. It's not defined for any negative numbers. So you can't plug a negative 1/3 in there because that would give you a negative logarithm. So that's why we only want the positive 1/3. But you do want to check it each time because if, say, like this was, well, maybe if it was like -2x in there, and then when you multiply it would make it positive. You want to double check it every time. Right? In this case, if we go back to the original problem and plug it in, only the positive one works. It's positive 1/3. All right, now we'll get to the last one here. Sorry, never mind. We got a little bit more of this one first. One more of this. Here's our last rule. This. 2 log 5 of x equals 3 log 5 of 4. And we can see we've got log 5 on each side, that's good. The only thing is we need to move those numbers, right? So take these numbers up to the exponents and rewrite it here as log 5 of x squared equals log 5 of 4 to the third. Now we've just got the log 5s and the numbers, so we can set them equal. X squared equals, now let's go ahead and do 4 to the third power. That's 4 times 4 times 4. What is that? 64. Yep. Which is good because that's a perfect square. So then we can square root. And then the square root of 64 is 8, right? And then we should just double check and make sure we don't want the negative 8 as well. This one does have just a plain log x, so negative 8 wouldn't work. So we just want positive 8. Alright, and now we're going to get to our last type here, our hardest one, yes, you could say. So this one looks even a little bit more different because it doesn't have a log on this side and a log on this side. You might have the thought that, well, you could sort of make it look like that. Give me a second to write down. Here. So you might think, well, we could just add this over, and don't write this for a second, but you might think, well, let's just add it over. This is a minus anyhow. So then we got a log on both sides. But the only thing is this also has a 2 here, and it's a 2 plus. So it's not just going to be a log equals a log. We got that plus 2 there. So this strategy is not going to work. The exponential one isn't going to work either. So here's our third strategy. If you just ignore this 2, and if I didn't give you any directions based on what we did the last few days, what would you do with this? Just ignore the 2. What? Okay, break it up, or how about the opposite? We can bring it together, right?
Yeah, this one.
Okay, yeah. Because it already is broken apart, right? So we call it condensing, right? Condensed logarithm. So you could actually bring this together into a single log, right? Okay. So let's try that. Let's try to condense this part. Again, ignore the 2 for right now. Try to condense this into a single log. Okay. And in doing so, we did the last couple of days, we take this up first, right? You look there. Okay. And then we've got log 3. That's our base. And then we take whatever's here. This will be in the top because it's positive, and this is a minus, so this will go to the bottom of the fraction. So then it would be log 3 of x plus 4 squared. And then the minus goes in the bottom, so over 9. Yeah. This is what we've been doing for a couple days, condensing, expanding logarithms. Okay. And then we still got equals 2. So we condensed it and we got it equal to 2. Now this is actually just a harder version of what we did with these ones, right? Where we got a single log. This actually is even the same base, almost exactly the same as this one we did earlier. Log 3 of 3x minus 1 equals 2. Just the inside's different. So we're going to solve it now the same way. We're going to do it in exponential form. So now we can do 3 to the second power equals this, right? So it's kind of combining those two together. And now we're going to do 3 squared and exponential equals x plus 4 squared over 9. This is where you got to know your algebra stuff here. Then solving this, which isn't too hard on this one. So again, from here we wrote an exponential and did 3 to the second equals this. 3 squared is 9. And 9 equals x plus 4 squared of 9. Squaring that 3. And then we're trying to get x by itself, right? So we then multiply by 9, right? There's 9 on the bottom. We get 81 is x plus 4 squared. Right. Then what next? Go to the square root, right? So square root. Now square root of 81 is 9 equals x plus 4. And again, you would actually have to consider plus or minus 9. But if you did a minus 9, you're going to end up with a negative, so you shouldn't have to worry about that. And then we'll subtract the 4 over the x equals 5. Yeah. Okay, what'd you do?
Well, after I condensed it, I expanded it and I got 1 for 4 is 1, and this is 1. So, then it was going to be x plus 4 equals 2.
Okay.
And then I'll just do like with the first step was after that I just wrote the lots of one like the exponential form.
Okay.
Just did it.
Alright, no worries. Yeah, so like in general, we're going to be condensing then exponential. So if you want to write that out in words, you don't have to, but you like to have like your 3 methods there. Words here. Our third one, what we did is we combined them into a single log, and then we rewrote it into exponential form. So depending on the type of problem, we're going to take one of these 3 approaches. And the problems I'm going to give you 2, I'll make sure to kind of note which one you're going to do. But they go in this order as well, kind of increasing difficulty. Easiest, and then get a little harder, and then a little bit harder. I want to do one more here. And then you guys can try some out. Yes, we get back. Yeah.
Could you go back to number 6?
Oh, sure. Yeah, sure. All right, so let's try one more of these here. There's going to be a factoring on this one, and I think there's one factoring one. That's the problem you're going to do too. All right, so this one's got 2 logs, right? And they're on the same side. So generally when you see 2 logs, same side, then we're going to be combining those logs together and then put exponential. This one's addition. Addition means multiplication when you bring it together, right? So this is going to become log 10, of this thing times this. So log of x times x minus 21. You can put a little time symbol that you want to as well. Addition, bring it together as multiplication. Equals 2. And you might even want to go ahead and just multiply this inside here. We do have to distribute this, so it multiplies both of them. So that then is log x squared minus 21x equals 2. All right, now we can go ahead and do exponential form. Just remember, if there's no number here that's a 10, so we're going to do 10 squared equals x squared minus 21x. Now, a little bit different from this point because we got x squared and we got x's and then we got a number over here. So obviously it's 100. Divided by 1. And then when you see something that has an x squared, it has an x and a number, it has 3 terms, you should generally think this is going to be a factoring thing, right? X squared, an x, and then a number, factoring. So how do we make that into something that we factor? Yeah, we want to move that 100 over. That equals 0. X squared minus 21x. Subtract it over, so minus 100 equals 0. And that looks a little bit more like something we're used to factoring. Okay, so from here then, we want to think there's going to be 2 sets of parentheses, right? We're going to put an x in the beginning of both of them. And then we've got to think what's going to multiply to give us negative 100. So multiply here. And add to give us this. So if you want to, you can like list out the factors. You got 1 and 100, 2 and 50. 3 doesn't go into it. 4 does, 4 and 25. 5 does, 5 and 20. And then 10 and 10. So those are your possibilities. Those all multiply to give you 100. And then we get negative 21 when we add them. And the pair that does that would be this one, right? 425, so we get 21. So you can just go through 4 and 25 in. Then you just got to figure out the signs. We need a negative 21, so you need a negative 25 and that's positive. And then don't forget to then solve these, so you just set each one equal to 0. Then we get negative 4 and positive 25. Now when we're done, don't just circle those just yet, because we got to make sure these are both answers that work. Don't always assume a negative doesn't work, but generally that's the case. If you take this and you try to plug it in, here we get a problem because we get log of negative 4. That doesn't work. You can try it on your calculator, it's going to say error, domain error. That doesn't work, so we can throw this answer out. This one, we get a solution, you can double check that. Log of 25, log of 25 minus 21, which is 4. You can also check your solution pretty easily on this one as well. If you did log 25, and then, plus log, this would be 25 minus 21, which would be 4, should equal 2. And then you could actually, from here, if you wanted to, you could combine these together. Log of 25 times 4 would be log of 100 equals 2. And then so you can think 10 to what power is 100? Well, 10 to the second is 100. All right, so you can also verify that that's true if you wanted to check it. So. All right, so we're going to stop there for today. Tomorrow we're going to do some more, a little bit harder ones. And I've got a few for you guys to practice of this for today / tonight. It's online there, and you can see there's a ton of these log equations, but I'm not gonna make it do them all tonight. We're actually gonna do the odds this time. We'll switch it up a little bit. So you're gonna do 5 through 17, the odds. The first two are similar. They're the first method where you're gonna do like 4 squared equals x. Okay, it's exponential. The next three, so number 9, number 11, and number 13, you can see you've got a log on each side. Right? And so you might have to rewrite it a little bit, like you might have to bring an exponent up or something. But you're going to solve the next three using the second method where you set the logs equal. And then the last two, number 15 and number 17, those are what we just did, where you got to combine the side and then use the exponential form. This one, combine the side and exponential form. So you got like your 3 different methods there. Your first two are going to use your first one. Your next 3 are going to use your second, and then your last 2 are going to use your third method there. Right. So go ahead and start on those, and